The universe is vast, mysterious, and constantly evolving. From the Big Bang 13.8 billion years ago to the incredible expansion of galaxies we see today, the cosmos has always been in motion, but like everything else, the universe too has an expiration date. Welcome to my channel, everyone. In this video, we'll explore the science behind how the universe will end, backed by the latest research and theories from cosmology. And we'll also attempt to answer an even bigger question: what comes after the end of the universe? Let's dive in. To understand how the universe will end, we need to look at how it's behaving now. The universe is expanding, and it's doing so at an accelerating rate. This discovery, made in 1998, earned scientists a Nobel Prize. It was thanks to observations of distant supernovae that revealed galaxies are moving away from each other faster than ever before. This acceleration is driven by a mysterious force called dark energy, which makes up around 68% of the universe. Meanwhile, dark matter, the invisible glue holding galaxies together, makes up another 27%. The remaining 5%, that's everything we can see and touch: stars, planets, and us. There are three main scientific theories about how the universe might end. Let's break them down one by one. The first, the Big Freeze, also known as the heat death, is the most widely accepted theory. As the universe continues to expand, galaxies will drift further apart. Over time, stars will burn out, leaving behind cold remnants like white dwarfs and black holes. Without new stars forming, the universe will gradually become darker and colder. Eventually, even black holes will evaporate through a process called Hawking radiation, leaving nothing but a thin soup of particles spread across an unimaginably vast and empty universe. This is the ultimate end state, a universe where no work or energy transfer is possible, effectively frozen in time. The second, the Big Crunch. It is the opposite of the Big Freeze. In this scenario, the expansion of the universe would eventually slow down and reverse. Gravity would overpower dark energy, pulling galaxies, stars, and planets back toward a central point. Over billions of years, the universe would collapse into an incredibly dense, hot singularity, essentially the reverse of the Big Bang. Some scientists speculate that this singularity could trigger a new Big Bang, creating a cyclical universe that endlessly expands and contracts. Finally, we have the Big Rip, one of the most dramatic theories. This scenario depends on the behavior of dark energy. If dark energy grows stronger over time, it could eventually overcome all other forces, including gravity. In this case, the expansion of the universe would accelerate to such an extreme that galaxies, stars, planets, and even atoms would be torn apart. This catastrophic end would leave the universe in a state of complete disintegration, with nothing but isolated particles flying apart at unimaginable speeds. So what comes after the universe ends? This is where science meets speculation, as we're venturing into uncharted territory. Here are some possibilities based on current theories. The first is eternal nothingness. In the case of the Big Freeze or the Big Rip, the universe might simply remain in an eternal state of nothingness. With no energy, no matter, and no time as we understand it, there would be no way for anything new to form. The second is a cyclical universe. If the Big Crunch occurs, it's possible that the universe could restart with a new Big Bang. This idea is part of the cyclical universe theory, where the cosmos goes through infinite cycles of birth, death, and rebirth. While there's no direct evidence for this, it's one way to reconcile the end of one universe with the potential for another to begin. The third one is the multiverse theory, which is another possibility. Some scientists believe our universe is just one of many, existing within a larger multiverse. If this is true, the death of our universe might simply be a local event, with other universes continuing to exist or new ones forming, independent of ours. Quantum mechanics and string theory offer some support for this idea, but it remains highly theoretical. Where does humanity fit into all of this? In cosmic terms, our existence is incredibly brief, just a blink in the timeline of the universe. However, as intelligent beings, we have the unique ability to understand and potentially influence our fate. Some scientists speculate that advanced civilizations might one day find ways to escape a dying universe, possibly by creating artificial universes or traveling to other dimensions. While this is purely speculative, it highlights humanity's drive to survive and explore. The end of the universe is a humbling reminder of how fleeting and fragile everything truly is. Whether it's through the big freeze, big crunch, or big rip, the cosmos as we know it will eventually come to an end. But this doesn't diminish its beauty or the significance of our existence within it. For now, we can marvel at the universe, cherish our place in it, and continue to explore its mysteries. If you enjoyed this video, don't forget to like, comment, and subscribe for more explorations into the wonders of science and space. Thanks for watching, and remember, our journey into the universe is just beginning.